This video is going to cover the commutative and associative properties of multiplication, the commutative and associative properties of addition, and finally the distributive property. In covering each of these properties, we'll define them and then look at a visual representation or justification of each. Lastly, we'll look at a numerical or algebraic example of each property. As we look at these properties, we'll let A, B, and C be real numbers or algebraic expressions. The commutative property of multiplication is the first one we'll look at, and it states that for two numbers or algebraic expressions A and B, A times B is going to equal B times A. And so, looking at that word commutative, to commute is to move something. So we can change that order of multiplication of A and B into B times A. And if we look at a visual justification for that, let's just look at a couple rectangles here. This first rectangle that I have drawn, I can look at having a side length of A and then a width of B. And now if I flip this 90 degrees, I'll have another rectangle, which I've got right here, and it would then have, again, short length of A and long length or width of B. And we know, based on geometry, that A times B is B times A. That just is our visual representation of what we're commuting here. If we look at an algebraic example, or actually in this case, let's do a numerical example. We know that 5 times 2 is always 2 times 5. And each side would obviously be 10. We're going to be able to extend this to further algebraic expressions as we look at this property more in depth. Next, let's look at the associative property of multiplication. To associate is really to group things. And so the associative property of multiplication says that if we take A times B and we group that with parentheses and then multiply it by C, that will be identical to having A times the grouped product of B times C. So what I've written is A and B in parentheses times C equal to A and then parentheses with B times C inside it. And so those products are equivalent. Now, looking at a visual representation of this one, here I have two identical rectangular prisms, and I'll label their sides with A, B, and C. So thinking of this one a little bit geometrically, if I take this first rectangular prism and I think about A times B, so I'll shade this surface A times B, or I'll highlight it actually, and then I think about taking that area and multiplying it by C, that's going to give me the volume of this rectangular prism. The other one is going to take that surface B times C, which I'll shade the top surface because I can see that easier with length B and length C, and think about taking that area and then multiplying it by that height A. That's going to again give me the volume. So all we're really doing here is grouping what we multiply first with that associative property of multiplication. The next property we're going to look at is the commutative property of addition. For a numerical example of this associative property of multiplication, let's just take 2 times 3, and we'll group that with parentheses, and then multiply by 4. And then we'll take 2 times the product of 3 and 4, grouped in parentheses. And as we can see on the left, 2 times 3 would give us 6. Multiply that by 4, we'd get 24. On the right, we'd be taking 2 times the product of 3 times 4, which would be 2 times 12, which of course is again 24. Next, we're going to look at the commutative property of addition. The commutative property of addition states that A plus B is equal to B plus A. And so again, to commute something is to move it, and so we're changing that order. A plus B is equivalent to B plus A. Thinking of this one simply for a visual example, we can look pretty simply at, here I have an apple and a banana, representative of two objects A and B. And if I take that apple and add it to the banana, looking at those as being put together, that would be identical to taking that banana and then adding in the apple. So total, I'd have the same for each of those. Looking at a quick numerical example, we know that with addition, when we take 5 and we add 2, that's identical to 2 plus 5. The next property we'll look at is the associative property of addition. And so again, associating or grouping things, this property says that if we take A plus B and add those two, so we group them, and then we add C, that's identical to taking A and then adding the sum of B and C that's been grouped in parentheses. So for a quick visual example here, I've brought up a picture of an apple, a banana, and a carrot, here representative of A, B, and C as objects. And so thinking of each of those groups are equal to each other. And so thinking if I first group this apple and this banana, and then add in the carrot, that'd be identical to taking that apple and then adding in the banana and the carrot. Looking at a quick numerical example, I'm going to take the numbers 2, 3, and 4. And if I take 2 plus 3, and then I add 4, that will be identical to taking 2 and then adding the grouped sum of 3 and 4. Looking at the left side, 2 plus 3 is obviously 5, adding 4 gives me 9. And looking at the right side, 2 plus that grouped sum of 3 and 4, which is 7, is also going to give me 9. The final property we're going to look at is the distributive property. And we say that multiplication distributes across addition. So formally, we summarize this property as A times the quantity of B and C, which we write as A parentheses B plus C end parentheses. And so we're going to say that multiplication distributes across addition. So if we have A times the quantity, or the sum of B and C, that turns into A times B plus A times C. And so looking at this is again another type of grouping property. So I'll give a visual representation here. So here I have 3 sets, or 3 apples and 3 bananas. And I've got them lined up, the apples stacked on top of each other as well as the bananas. And thinking about taking each apple plus a banana and then grouping them. I've got 1, 2, 3 of those. What this property is saying is that I could group them differently. I could group them into 3 apples and 3 bananas. And so looking at that then, I've got those grouped. It's really just a matter of grouping them differently. So if we look at, I'll do an algebraic example here as opposed to just a strictly numerical one. But if we look at an example here, we can think about taking 3 times that quantity A plus B, and that will turn into 3A plus 3B. And that's our property, distributive property, which shows that multiplication distributes across addition.